Distance, force, velocity, work done, time is irrespective of direction. It has only magnitude, so therefore it is scalar. So what are collinear vectors? Two vectors are said to be collinear if they are parallel to same line. And its initial point is A and terminal point is B, and it is directed from A to B. So this is a vector. So acceleration means what? Rate of change of velocity. So it depends on direction. They are called co-initial vectors. Co-initial vectors means what? Which will have collinear vectors means what? Two or more vectors are said to be collinear if they are parallel to same line, irrespective of magnitude and direction. Welcome to the session, dear students. Today I'll be starting with an important chapter, that is vector algebra. Vector algebra plays important role to understand three-dimensional geometry and also many other applications in physics and mechanics. So now, starting with this, what is a vector? So when we consider what is a vector, so you would have already studied in your physics, vector is a physical quantity which will have both magnitude and direction. It will have magnitude as well as direction. Or we say directed line segment is a vector. Or we can also say what? Directed line segment is a vector. Line segment is also called as what? Vector. Now coming to this, we'll take some simple examples. So I'll consider a line from A to B. It is directed from A to B. This is a vector. And its initial point is A and terminal point is B. And it is directed from A to B. So this is a vector. A directed line segment is a vector, or vector is a physical quantity which will have magnitude as well as direction. It should also have a number value associated with it, and also it should have direction. Then we call it as what? Vector. And different types of vector. Now all of you know what is a vector. Now types of vector. So different types of vectors. If I take two vectors like this, say this is vector A and this is vector B. See, both are starting from same point. We call them as co-initial vectors. Co-initial vector. What are co-initial vectors? Vectors with same initial point. And the other important definition is collinear vectors. See, this is a key concept of the chapter. So many times in your board exam, they'll ask define collinear vectors. What are collinear vectors? So two vectors are said to be collinear. Two vectors are said to be collinear if they are parallel to same line, irrespective of magnitude and direction. For example, I'll take vector A and I'll take vector B. See, now I can say these two vectors are collinear because they are parallel to the same line. Or I can say I can draw a parallel line common to both. So now vector A is also parallel to L and vector B is also parallel to L. So for these two vectors, we can draw a common parallel line, therefore they are collinear. So what are collinear vectors? Most important definition in your board exams, and the concept is also equally important. Collinear vectors. What are collinear vectors? All vectors are not collinear vectors. Collinear vectors means what? Two or more vectors are said to be collinear if they are parallel to same line, irrespective of magnitude and direction. Or we say if they have common parallel support. So what are collinear vectors? So two vectors are said to be collinear. Two vectors are said to be what? Collinear if they are parallel to same line. Said to be collinear. We can call them as collinear if they are parallel to same line or if they have same parallel support. So two vectors are said to be collinear if they are parallel to same line. If they are parallel to what? Same line. Parallel to same line and irrespective of magnitude and direction. We are not bothered about its length and direction. irrespective of magnitude and direction. Very important. Irrespective of magnitude and direction. Understanding collinear vectors is important. Irrespective of magnitude and direction. So dear students, what are collinear vectors? Two vectors, you can call them as collinear if they are parallel to same line irrespective of magnitude and direction. For example, so here I'll take vector a small vector, and I'll take a big vector, vector B, and both are having opposite directions. But they are collinear because for both put together I can draw a common parallel line. And I'll take vector AB and vector BC. Again, these two are also collinear because for these two put together I can draw a common parallel line. And I'll take one vector, vector A, and opposite vector minus A. Minus A means negative of a vector. What is meant by negative of a vector? A vector which will have same magnitude as that of the given vector but opposite in direction is negative of a vector. So vector A and minus vector A are again collinear. So now, what are collinear vectors? Two vectors are said to be collinear if they are parallel to the same line irrespective of magnitude and direction. We are not bothered about their magnitude, we are not bothered about their direction. Most important. And along with that, you should also know equal vectors. What are equal vectors? Equal vectors, two vectors are said to be equal vectors if they have same magnitude and same direction. So equal vectors means what? Two vectors are said to be equal. They should have same magnitude. Both should have same magnitude, same number value, and they should also have same direction. Both should match. So depending on the simple concepts, we'll start solving the first exercise of vector algebra. So that is exercise 10.1. So now represent graphically a displacement of 40 km 30 degrees east of north. 30 degrees east of north it is. So first we'll draw the quadrant system, that is here we say east and this is west and north, south. These are the directions we plot. This is east, opposite is west, and left to east is north and south. They want 30 degrees east of north. Of north means from north 30 degrees. East of north. The question is, this is east of north. East of north. What is meant by east of north? Of north means you should make an angle with respect to north. So, this is the line segment. So, this is the line segment. So this is a line segment. It makes 30 degrees with what? North towards what? East. East of north means from north 30 degrees towards east. This is east of north. And what is this? This is a vector and they told 40 kilometers. So if I say vector A, its magnitude, the length is 40 kilometers. We read this as magnitude is 40 kilometers. This is vector A. This is the representation. Next, classify the following measures as scalars and vectors. Scalars and vectors. What is a scalar? Scalar is a quantity which will have only magnitude. It will not have direction. What is vector? Vector will have both magnitude and direction. Now starting with this 10 kg. First one is 10 kg. 10 kg is mass, a unit of mass. 10 kg is mass. So for the first one, in the second question, the first one, 10 kg they told. You know, kg is what? Mass. Mass is what? Mass is a scalar. So therefore it is a scalar. Question 1 is scalar because it has only magnitude. It has only what? Magnitude. It does not have direction. Therefore it is scalar. And the next one, second one, 2 meter north of west. 2 meter north west they told. Please understand 2 is magnitude. Northwest is direction. So it has magnitude as well as direction. Therefore second one is what? Vector. It is what? Vector. So now we are done with this. First one is scalar. Second one is vector because it has magnitude as well as direction. Third one, 40 degrees. 40 degrees is angle. 40 degrees is just an angle. It has only number value, magnitude. It does not have direction. Therefore, third one is what? Scalar. So, since 40 degrees, we have only magnitude. We don't have direction. So, it is a scalar. And fourth one, 40 watt. So, unit they give. 40 watt. All of you know watt is the SI unit of power. So, power, the SI unit they give. So, we are not bothered about direction. It has only magnitude, therefore it is scalar. So, fourth one is also what? Scalar because it has only magnitude. 10 power minus 19 coulomb, it is the SI unit of charge is coulomb. So, this is also scalar. So, fifth one is also what? Fifth one is also scalar. Fifth one, 10 power minus 19 coulomb. Coulomb is the unit, it does not give direction. So, it is a scalar. And 20 meter per second square, sixth one. Say 20 is a number. Meter per second square is acceleration. This is acceleration. So meter per second square, we measure. It's a measurement of acceleration. That's what you studied in your 11th standard physics. So acceleration means what? Rate of change of velocity. So it depends on direction. So therefore 20 meter per second square is unit of acceleration. Acceleration depends on magnitude as well as direction. So it has magnitude 20. Direction is also in the form of acceleration. Therefore it is a vector. Acceleration is vector. So now the last one is what? Vector. We are done with this. So they want you, the question number 1 is what? Classify the following into scalars and vectors. You know, scalars means what? Which will have magnitude but no direction. Vectors means what? Which will have magnitude as well as direction. So if you want to classify, so first question, third and fourth, fifth. 1, 3, 4, 5 are scalar and 2 and 6 are vectors. Next we have classify the following as scalar and vector quantities. You know, a physical quantity which will have only magnitude, we call it a scalar, and a physical quantity which will have magnitude as well as direction, we call it as vector. So first one, time period. You know, time period will not have direction. So therefore, the first one is what? Scalar. So time period is scalar. Time period is what? Time period is scalar. So then we have the second one. What is the second question? Distance. So distance, they give distance. Distance, again, when you take, it does not have distance, 10 kilometers, 20 kilometers. Distance does not have any direction. So it has only magnitude. It is a scalar. Distance is a scalar. Whereas displacement means it will become vector. Then third one we have. So what is the third one they give? Force. You know, force depends on direction in which you are applying. So force will have magnitude as well as direction. Force is vector. Force is what? Vector, because it has both magnitude as well as direction. And fourth one, velocity. You know, velocity means what? Speed in particular direction. Velocity is speed in particular direction. So velocity will have magnitude as well as direction. So velocity will have magnitude as well as direction means velocity has to be what? Vector. Velocity has to be vector. Then work done. Work done is scalar. So they are not mentioned by the system or on the system, or they have not considered the direction here. So work done is, again we say scalar. Work done is what? Scalar. So I hope you understood all these things. They want you to classify them as scalars and vectors, and they give time period, distance, force, velocity, work done. You know, time is irrespective of direction. It has only magnitude. So therefore it is scalar. Therefore it is what? Scalar. And distance, it has only magnitude, no direction. Therefore it is scalar quantity. Force will have magnitude as well as direction. So therefore it is vector quantity. And velocity is speed in particular direction. So velocity will have magnitude as well as direction. Therefore it is vector. And work done is scalar. So these are the important quantities where we classified them as vector quantities and scalar quantities depending on simple definition what is a scalar and what is a vector. So what is a scalar? Scalar means what? A physical quantity which will have physical quantity which has only magnitude but no direction. Scalar definition. What is scalar? A quantity which has only direction, only magnitude, sorry, only number value but no direction. But no direction. We are not bothered about direction here. And what is the vector? A quantity which will have both magnitude as well as direction. It has both magnitude as well as direction. So knowing this basic definition, you can classify. It has both magnitude and what? Direction. So now if I take a simple line segment, say here the line segment, this is line, but if I put an arrow mark, it is vector, and if it is 5 centimeters, now I'll say it is directed from A to B direction. Magnitude or length of this is what? 5. Number associated is magnitude here. It has both magnitude and direction, like that. Then in the figure, identify the following vectors. They want co-initial vectors. Co-initial vectors means what? Which will have same initial point. In the diagram, A starts from this point and also D starts from this point. So vector A and D, what are the co-initial vectors? Vector A and vector D are co-initial. And second one, equal vectors. Equal vectors means two vectors are said to be equal if they have same direction and same magnitude. They should have same magnitude, length should be same, and also they should have same direction. So in the diagram, vector D is going downwards. This is the direction in the problem. Vector B is also going downwards and they are equal. So therefore they are equal as well as they have same direction. That's why equal vector means I should pick vector D as well as vector B. And collinear but not equal. Collinear vectors means what? They should be parallel to same line. So now vector A and vector C are collinear. I can draw common parallel line for A and C. Vector D and B are also collinear. Vector D and B are also collinear, but they want collinear, very interesting, they want collinear but not equal. They should not be equal. So therefore, I can choose only, what is the answer for this? Vector A and C. These are collinear, but they are not equal. Why they are not equal? Because A is going from left to right and C is going from right to left. The directions are different. A is this and C is this. So their lengths are equal, but the directions are not equal. What are equal vectors? Two vectors are said to be equal if they have same magnitude and same direction. So they want collinear. So we have AC is also collinear, BD is also collinear. But BD not only collinear, BD are also equal. They want collinear but not equal. So I have only one go, A and C. So what are collinear vectors? Two vectors are said to be collinear if they are parallel to same line. What are equal vectors? Two vectors are said to be equal if they have same direction and same magnitude. So we have done the 3 questions what they asked. Then answer the following as true or false. Vector A and vector minus A are collinear. Yes, true. Why? Because vector A and vector minus A, negative of a vector. Negative of a vector means what? It will have opposite direction. For both we can draw a parallel line. So collinear. Two collinear vectors are said to be equal. Always equal in magnitude. Not necessary. False. Why false? Because collinear vectors means what? They should be parallel to same line. We are not bothered about magnitude and direction. While defining, I taught you, two vectors are said to be collinear if they are parallel to same line irrespective of magnitude and direction. We are not bothered about magnitude and direction. So it is not necessary they should have same magnitude. They may have different lengths. See, I will draw two collinear vectors. So now vector A, a small vector I will draw. Vector B, I will draw big vector. So these two are collinear because for both put together I can draw a common parallel line. So vector A and vector B are collinear, but they are not having same length, same magnitude, you can see. So therefore, two collinear vectors are always equal in magnitude, they told. No, false, not necessarily. Then two vectors having same magnitude, they have same length, are collinear. No. When can you say collinear? You can say they are collinear if they are parallel to same line. So they told same magnitude means collinear. Same magnitude, say I will draw one line like this, 5 centimeter. Directed like this. Another vector I will draw like this. It is also 5 centimeters. Both are having same magnitude, but they are not collinear. Why they are not collinear? I can't draw common parallel line for both. If I draw a line parallel to this, it will not be parallel to this. Or if I draw a line parallel to this, it will not be parallel. So they have same magnitude, but they are not collinear. So two vectors having same magnitude are not collinear. They are told are collinear, it is false. And two collinear vectors having same magnitude are equal. Two collinear vectors having same magnitude are equal, they are telling. So now for fourth one, let me take one simple example for fourth one. Okay, here I'll take. So two vectors. See, what is the fourth statement? Two collinear vectors having same magnitude. I'll take same magnitude. So one is from A to B. Say magnitude is 5. And the other one, same magnitude, are equal, they told. Other one I'll take. Say I'll take C to D. CD, but directed from D to C. So please observe this. This is also 5. Say. Both are having same magnitude, but they are not equal. Why they are not equal? Directions are different. This is going from left to right, this is going from right to left. So two vectors are said to be equal if they have same magnitude, and direction also should be same. But I can call these two are collinear, but not equal. So two collinear vectors having same magnitude are equal, they told. They have same magnitude, they are not equal. Why? Because their direction may be different. So last one is also false. They are collinear. So I showed the diagram. They are collinear, but they are not equal because their directions are different. Magnitudes are same, directions are different, but collinear. All collinear vectors need not be equal vectors. All equal vectors are collinear. So four statements. The first one is true, second one is false, third one is false, and fourth one is false. To answer this, first you should know what are collinear vectors. What are collinear vectors? Two vectors are said to be collinear if they are parallel to same line irrespective of magnitude and direction. When we are bothered about collinearity, we are not bothered about direction and magnitude. And equal vectors. Two vectors are said to be equal if they have same direction and same magnitude. Same direction, same magnitude, then equal. Collinear means magnitude and direction may be anything, but they should be parallel to a common line. So these are the concepts of the exercise. So I hope all of you understood. I'll see you in my next session. Thanks for attending. Thank you.